Hi, thank you so much for applying to Healthcare Data Science Immersive Scholar, like a summer internship program. So I'd like to introduce myself. I'm Mohammed Arif Alam. I'm an assistant professor in jointly in computer science and also Department of Medicine in University of Massachusetts Medical School. So here a few of the project I'd like to mention that I have interest. The first one is the wearable sensing for healthcare data science. So in this particular project, we have a very big data, like almost more than 300, like more than 600 participants wearable data. So we have this is called particular like the all of us data. So in this data, you can check it out, this data in this particular link. So this data they collected longitudinal the Fitbit data. The Fitbit data does have the heart rate and step count in every minute. And this data has a few more things along with this Fitbit wearable data. So these few more things includes the survey questions and hospital records where you have the diagnosis report and their mental health surveys, their experience surveys, and many more other things. Among these 600 participants, I think almost more than 200,000 participants have some form of like the coronavirus infections or some kind of symptoms. So this particular project, I'm interested in like the how we can use this wearable sensor data combining with the hospital record and survey questions to predict some of the important things that we are not able to predict using any like that much easily. So one project been done, one of my PhD students, that is wearable sensor based pain assessment for people who has disabilities. So the codes and tutorials will be provided along with that, and several few projects in my mind. Like that one is a very important project, like opioid addiction detection and prediction from wearables. You will be like if you're in a good state. So there will be collaboration between University of California, San Diego. So so how we can predict the opioid addiction event using these wearable sensors. So we have the opioid addiction like the event labels. So all you need to find that and train your machine learning model. And also another interesting like the project is like the predicting schizophrenia episodes from wearables. So in this large data, we have few schizophrenia patients data as well, and their episode labels as well. So the idea is we would like to predict the schizophrenia like the episode from wearables before it happens, thus they can take necessary initiatives to avoid that. And that is a life-saving like the project could be there, and we have enough data, and all we need to sit tight and work on few machine learning algorithms. And there's another like the project idea is like the self-evaluating COVID-19 severity from wearables. Like sometimes we don't know whether we need to go to like the hospital based on my like the home kit provided the COVID-19. So the wearable sensor can actually help to identify whether your heart rate, step count, and many more other activities, whether they are actually involved with some severity, thus you should go to the hospital or not. So the central takeaways from these projects are like you learn the signal processing of wearable sensors, data science, time series data analytics, and deep machine learning. And there should be one or more publications. All of the like the cost involved with the publication, like the registration and travel expenses, will be covered by my lab. So second project that I have in my mind, that is artificial intelligence ethics. In 2019, researchers found that an algorithm used in US hospitals that has been used to find whether the patients should take like the patient should consider as an emergency based on the patient's symptoms. And it has been found that this algorithm is somehow in the hidden secretly inside that algorithm is deciding that the Black patients are considerably ignorant in this like the this scoring method. And it is not only this hospital like the scenarios. There's several other things happen, like in Amazon's software engineering job, auto CV filtering algorithm, that is an AI algorithm, and it also found that it's significantly rejecting female like the applicants, like the it's auto filtering out the female applicants without noticing their other contents of the CV. So these are all AI algorithms that has been blindly trained based on the some of the evidence of the success. So, but somehow these algorithms are actually biased based on the sensitive context like gender or the color or race. So this has been really talk of the topic these days. So such a bias happen under like the any sensitive context such as physical disability, race, age, cognitive ability, or skin color. And the biggest question is how we can detect such a bias and mitigate them. So this work is particularly focusing on detecting and mitigating such a bias. Where does the artificial intelligence algorithm cannot be providing like the different decision based on the person's color or person's gender. So we have already did a preliminary work like the AI bias mitigation on variable-based pain assessment using existing algorithms, where the codes and tutorials will be provided. But I have a project in my mind like whether the COVID-19 risk prediction bias can be detected or mitigated. Or also we can actually explore many more other like the side we can improve the existing bias mitigation techniques using reinforcement learning. So you will learn from this project signal processing, data science, time series, data analytics, just like before, but additionally learn reinforcement learning. And there should be a few like the publications if you have improved results. So the causal inference is a special field of like the machine learning that has been used to find the causation. So in normal machine learning algorithms or AI algorithm, they use mostly the correlation features, but the correlation is not causation. So just like here, one example you can take a look there in the state of Maine, there from 2000 to 2009, there has been statistics that the margarine consumption is the black one, the margarine consumption's rate over the time, and you can see that like the divorce rate in Maine has been plotted in the red line, and you can see that there's a highly correlation between these two terms, like the virtually, and they are virtually correlated among each other. That means if the machine learning algorithm takes the margin consumption statistics and it can predict what will be the divorce rate in Maine this year. But this is like the totally absurd, and it cannot be happen. And the thing is, yes, the prediction can be really like accurate, but this is not logical. So we need some of the features, some of the context that is logically related to the outcome we want. So this logic is called causal inferences. So that means these are correlated, but margarine consumptions does not cause the divorce rate. So how are you going to identify that, whether these margin consumptions is actually causing the divorce rate or not? This identification method is called the causal inferences, whether a particular particular context is responsible for it, another one. To identify that is particular science is called causal inference. And this is really important these days in computer scientists. In 2018, Judy Pearl, the writer of the book of Why Causal Inferences, he won the Turing Award for writing that book because it's really important in machine learning these days. So the causal machine learning is really helpful in identifying true causes of an event. Like some of the questions could be like, does multiple substance consumption increase the risk of hospital mortality, or does common drugs you're consuming today has a potential risk of future hospitalization, future mortality in hospitalization? You don't know these questions, and correlation cannot give you the answer. There could be some correlation, but there might not be the causation. So all of these questions cannot be answered using statistical analysis or on machine learning algorithms. It requires the causal inferences. So we have completed a preliminary work on antidepressant drugs usage that actually reduce the risk of COVID-19 mortality. So the codes will be provided, and tutorials will be provided for these particular projects. So in this project, so we will be utilizing a data set. It's a very long data set, like 80 million patients data sets, is called National COVID Collaborative Cohort N3C data. So you'll be given permission to access these data. It has 18 million patients of hospital reports. Among them, 7 million are COVID patients. So the one project in my mind like that in long term or long COVID, what would be the potential health risk factors among COVID survivors? So these potential risk factors could be depression, anxiety, or like even the suicide tendencies on the cancer, and many more other things. So we don't know whether this COVID infections actually causing those kind of like the future health hazards or not. So this causal inference method that we are going to introduce that can be utilized to answer those questions. So see a few project ideas in my mind, like whether the COVID survivors are getting really depressed more than before that, and also whether the COVID, the survivors may increase the risk of cancers or a dementia or an antibiotic resistance among survivors that we don't know, and we can use the causal method to know. So, and also the takeaway from this project is like that you learn the industry level big data analytics, data science, causal inferences, bioinformatics, and drug delivery discovery. So there should be multiple publications opportunities along with my PhD students. And the final project that I'm really interested in, graph neural network. The graph neural network is a present hype among deep learning community due to its immense power of learning in noisy, unstructured data. So if you take a look there, the graph neural network is a special kind of neural network that has some nodes, these kind of nodes, and each node are connected with each other some edge. And you can predict the node and you can predict the edge. And there's a lot of opportunities. You can see that you can learn many complex like the data using this kind of unstructured graph neural network. So the graph, we have collected the particular project that I have in my mind is the water contamination detection. So we have collected water contamination level, like the lead and copper level from houses in Massachusetts, and got some data from Michigan. So, and we are interested in predicting the water contamination level on the houses we could not collect data. So we can consider each of the house as node, and the neighboring house can be their connected edge. So we can easily develop a graph neural network, and we can try to predict the node or node classification. And that will be really helpful for us to send the people to the house, those are really highly risky, and collect the data and cross-check that whether our prediction is correct or not. So we already completed a graph neural network for traffic congestions predictions. So there's a codes and tutorials will be provided, and central takeaway like the learning, the deep learning graph neural network and environmental engineering, and you should have multiple publications. There's a few PhD students of mine working on that, and cost will be covered. And there's another interesting fact about this graph neural network project is that you have, if you do really well, there's a potential that you would be rehired for the next semester, as a part-time employee in my lab, because I have a major grant. It's a $2.5 million grant on this project, so that you can participate. So one more thing I'd like to mention, that there over this internship, you'll have the 3 phases, 3.5 months. There will be 3 phases. We can define this 3.5 months of internship. So the first phase is the learning phase. In the first month, you will be provided a lot of tutorials, a lot of code samples, and you will be assigned a PhD student as your mentor. So you will learn whatever has been given to you, and you will re-implement everything that we already did, and you learn everything well. So the second month, that will be starting with the data that we have. You will be given the data access, and you will be asked to implement some of the existing the method on the data that we have. So this challenge will give you the deeper understanding how to work with the real world data, and you will be learning how to handle the different challenges and solving that one. And the third month will be the innovation month, where we are going to talk about what new thing we can add to improve the accuracies of the of your method, and where we are going to implement like the new ideas. We'll try and find the error, and finally, if we have some progress, then we are going to talk about like the next step. And last 15 days of this internship, you will be documenting everything in a report, and I'll be helping you to like the write that report, and we'll be learning how to write like the scientific manuscript in the last 15 days. And if everything goes right, we'll be submitting a paper at the end of this like the summer together. I have a very good track record of publishing papers from the Immersive Scholars. I have 3 Immersive Scholars so far who published like the 4 different papers, collaborating with my PhD students. And I have track record. I have very good outcome among the like the Immersive Scholars. One of my Immersive Scholars joined in like the Visa as a software engineer. Another Immersive Scholar actually joined in Microsoft as software engineer, who worked with me like the 3 years ago, 2 or 3 years ago. So I'd say that like the please take a look in this presentation again and again, and decide which project you have interest, and we are going to talk about more details in one like the interview session. Thank you so much